Mastering functions is going to make your life a gazillion times easier. Because when we're working with the code, we start ending up getting really long programs that are hard to figure out what's doing what, and they're not very organized. You can throw in a bunch of comments, but at the end of the day, it's a pain in the butt to try and figure out what's really going on and how it's structured. A good practice when you're doing any type of programming is to take the lines of code that are performing a specific task or activity and encapsulate those into a specific named function. And then all we have to do is call that function when we want to use it. And one of the biggest bonuses there is there's many times where we will want to call upon that set of instructions at more than one point within our program. So instead of repeating those instructions, all we have to do is just call that function again. So it makes it more organized, it makes it easier to follow, and it actually makes your code more efficient. And it also, for a lot of people, helps to start to organize your thinking, because as you've worked on your programs, they're starting to just look like a bunch of repetitive, meaningless lines that you stare at it and I don't really know what's doing what anymore. But when you organize it into functions, you're being much more intentional about these lines of code are doing this one task. These other lines of code, a different task. And by organizing it that way, it makes things better. So in the functions file that we're starting with today, I've commented out a couple of functions that I'll be calling upon in a little bit, because in my draw function, if I hit go and watch this, we see that, okay, here's the bouncing red ball. It just bounces, la-di-da, not very exciting. But there's a couple of things that are going on with this. Each frame draw runs, it has to clear the background. And then each frame it needs to update the position of the red ball. It needs to check and see, has the red ball hit a boundary, top or bottom? If so, change its direction. And then it also needs to display that red ball. So there's instructions for doing each one of those specific tasks. And if we realize that we can organize our code in that manner, it suddenly will make everything a whole lot more readable, because we're thinking about these are the 4 things that are happening every time draw runs. We need to clear the background. We need to update the position of the object. We need to then verify if the object has hit the boundaries. If so, further update it. And then finally draw it. So we're going through this stepped ordering of processes. So to do that, and stop that, what I can do is I can take these pieces of code that are currently in my draw function here. Well, wiping the background is, oh, I forgot I can't drag and drop here. So I am going to copy this, comment that out, and then put it over here. And just get rid of the extra part there. Now, updating the object, the update is y plus equals speed y. So I can copy that, comment it out, put that under update. Now drawing the object, these lines of code, copy that, comment them out, and now put that in display. And then finally my boundary check, finding out have I actually hit the boundary. Now if I go ahead and run this, we will see a gray box happen and absolutely nothing is going to occur. That's because I haven't now taken my named functions and made them available. Now, I could have cut these or deleted these afterward, but anytime I'm reorganizing or refactoring my code, the initial movement of things, I always like to just comment stuff out, then put it where I think I now want it, versus deleting, because that process of getting rid of things, invariably stuff gets lost. So I find as a final step, I'll go and delete all of that old stuff that's commented that I'm not using anymore. But in the beginning, right now, I find it's better to have it organized like this. So now if I hit run, we're right back to where we were when we started. So that was a lot of work for not a lot of overt benefit. But if I get rid of these just so it's a little bit cleaner to look at, now my draw function, instead of being a whole bunch of lines of code that I have to think about, okay, what does this do? What does this do? And I may have put a comment or two in, but by having a named function, I've now organized and structured my code into a much more usable form. And if I decide my background, instead of wanting to just wipe it and fill it with the color gray, I have a new idea that I want to try. So I am going to instead set my fill color to gray, but transparent gray. Remembering if I specify two colors, it's a grayscale value and an alpha value. Otherwise, I could say 128, 128, 128, RGB A for my alpha. So I could specify those 4 values there. And then say rect 0, 0, width, height. So it draws a rectangle that fills the whole screen. Now, take a moment and think about what this is going to do. Hit run. I see we get a little bit of a trail. Now, if I decide that I want that trail to be even longer or more pronounced, so we see how we can start to create that movement trail. So instead of wiping the background saying erase what's there and just fill it with the solid color, I can now instead fill it with a transparent color, so it leaves a remnant of where it's been. Look at my code, it makes a little bit more sense of what's going on because I'm clearing the background, well, sort of. I could rename that into something else of, paint out background, but I'm dealing with the background. Clear background is enough to get our attention of what's going on. We're updating the object, we check the boundaries, and then we finally display the object. So now all of this code that I have here, if I decide it's not an ellipse but it's a box, I can just go change what's in my display and it updates. Later on, when we have more complex objects, images and things like that, change what's in the display, leave everything else, our code still works. So as we start to build more and more complex programs, what we're going to find is the pieces that we've put together, we don't even have to touch anymore except for certain things, because often the core of it is done. All we're doing is changing the skin, the paint that we put on top, which makes it a lot of fun. When we're working with a function, the core and in the file here up at the top commented out, we have return type, the function name, and then a data type argument if we put it in. Then we do something, and then we return something if our return type was not void. So if it's not void, we return whatever that was. That's the core kind of structure for a function. And we've already been working with functions: setup, draw, fill, rect. All of these things are actually just function calls. We have a name and then we have some parentheses. So when I call rect, I'm actually calling the rect function, and then the rect function is taking these 4 values, and what it does is its instructions when you call it is to draw a box on screen at whatever those values are. So it's a function that does that, but it's built into the language. So we don't have to use only built-in functions. We get to make all our own functions as much as we want. And sometimes we realize that there's a shortcoming in the language. We want it to do something that's not there, so we build a function to do it. And that's a normal part of doing coding and programming is you want to do something. If it's built in the language, you use the pre-built functions. If it's not built in the language, you write your own. And then you work with it that way. So a lot of what we're going to do, we're moving beyond this concept of like using all pre-built. So if you think about, say, HTML, you're making a web page. The language is fixed. There's a finite number of tags that you get to use. So you have body, HTML, title, head, paragraph, headlines 1 through 6. We have lists and unordered lists and list items and just, a bunch of tags. Divs, spans. These are just tags, but it's a fixed language. You can look it up and memorize the entirety of it. But when you're coding, you have the core language, but then you get to build upon that core language and construct your own solution. So you are, in essence, extending what's there because you're not just working with everything pre-built. To me, that makes it a whole lot more exciting and a whole lot more interesting because now you are in the driver's seat. It's not just you working with what other people have done and then bitching and moaning about it because, well, you don't like how it is or it implements poorly across different browsers and it's super annoying. It's nice when you get to be in charge of things. So we have the return type, we have the function name, couple parentheses if this function is going to do something, then we throw a curly brace, closing curly brace, and in between it we have the instructions of whatever that function is going to do. That's the core structure of how we will write a function. Again, the majority of our functions will all just be void and then whatever we want to name it. The same naming applies for functions as it does for variables, that we can use letters, could use numbers. Typically functions always are just letters, multiple words camel cased together as a good practice. First word lowercase, the next word starts with a capital. That's a standard method of working with functions. Make your function names long enough that they're meaningful. If you make them really short, when you read the code, it's really hard to figure out what's going on. More typing makes your code more legible and will ultimately just, I think, make it more understandable and easier for you to debug at 3 o'clock in the morning when it's giving you all kinds of error messages.